seen how we can use the Carnot map method to minimize switching functions. We had looked at 3 and 4 variable functions as examples, and we have also mentioned that we can go up to maximum 6, not more than that. So, today we shall be discussing some method which is sometimes called the tabular method, which is more systematic in this respect. Let us first look at the motivation why we are trying to go for this. We have already mentioned that in the Carnot map method we can go up to maximum 5 or 6 variables. More importantly, it is not easy to automate on a computer. You see, whatever you do, whatever design minimization we do today everything is done on a computer, right. This Carnot map which you are doing with hand, very nicely you can visualize, you can write down the expression. But you think, if I have to write a computer program to do this will not be so easy, quite complicated. Finding out the visually the maximum size, the cubes, try to make them largest, not so easy. So, Carnot map is not so easy to program and automate. Okay? This is one problem. So, to remove this drawback, say for larger functions and also from the point of view of automation, we need a more systematic procedure. There is a systematic procedure which was proposed by Quinn and McCluskey, which is sometimes known as Quinn-McCluskey method. Because it uses some kind of a tabular structure, it is also referred to as tabular method sometimes. This method has an advantage that this can be automated easily, and also you can also do it for hand computation, as we shall illustrate with some examples. But automation is easy, you can write a computer program for this in a much easier way. But what is the basic idea behind this approach? The idea is very simple. We already know an identity like this, that any subfunction multiplied by a variable x plus that subfunction multiplied by x bar, if you take a common, x and x bar goes, you get only a. That means, one variable gets less, becomes less. So, if you repeatedly apply this simple rule to all adjacent pair means which differ in a single variable. So, if we repeatedly apply this, the concept is whatever you get at the end, they will only be the set of prime implicants. So, you start with all your true minterms, go on applying this rule repeatedly on wherever you can. At the end, where you see that you cannot apply this rule anymore, you will find that whatever you are left with, they are the prime implicants. And prime implicants are something which will make your final minimized expression. Some set of prime implicants you will have to select after that. Okay. This is basically a two-step process. First, generate all the prime implicants. Second, select the minimum set of prime implicants that can cover the whole function. Okay. Let us see how it works. So, a very simple example, let us first illustrate with the help of an algebraic expression. Consider a 4 variable function like this, there are 4 product terms or 4 min terms. You see, there are some min terms which differ in one variable, like let us say a bar, b bar, c bar, d bar, and a bar, b bar, c bar and d, they are adjacent, and similarly a, b bar, c bar, d bar and a, b bar, c bar, d, they are also adjacent. So, you can combine the first two and the last two terms, you can take them common. So, d disappears, here also d disappears, you get a bar, b bar, c bar plus a, b bar, c bar. Now, you can go on applying this repeatedly, again you see here again you can apply the same thing. they are again adjacent, they differ only in A. So, you can again apply the same rule and you get finally B bar C bar. Now, what is B bar C bar? B bar C bar is a prime implicant. So, the idea is as follows: whenever you have these min terms, go on applying this rule whenever possible, how many times possible, ultimately you land up with something, those will be the prime implicants. We go on combining any pair of product terms that differ in a single literal value. This is the basic idea behind the tabular method, which we shall be illustrating with some examples. Okay. Let us now look at the basic concept, what we do in the tabular method. Two k variable terms can be combined by an application of that rule that I mentioned to form a single k minus 1 variable term. Here an example is given: A bar, B bar, C bar, D, 4 variable term, there is another 4 variable term, you combine them, what you get, this A disappears, you get B bar, C bar, D, 3 variable term. Here k equal to 4, k was 4, after combining you get a single k minus 1 variable term. This is possible if and only if the two terms differed in a single literal. Here they were differing only in A bar and A, B bar, C bar, D was common, right. For convenience, we use the binary representation. A bar, B bar, C bar, D we write as 0 0 0 1, 0 means bar, 1 means uncomplemented. Similarly, A B bar, C bar, D we write as 1 0 0 1. So, we have 0 0 0 1 and 1 0 0 1. So, wherever there is common, you keep them unchanged, and wherever they are different you put a dash. Okay. So, you get dash 0 0 1, which means B bar, C bar, D, A has vanished. This is the idea. So, in this binary representation we are using the symbol dash to indicate the absence of a literal. So, in the tabular method we use such binary representation, this dash, to manipulate such min terms and apply these minimization rules. So, the steps of the tabular method, broadly the first step, that means identification of the prime implicants, that part of it. There are 3 steps. First is that we identify all the min term in the true min terms, of course, the true min terms in groups based on the number of ones in the min terms, and the number of ones in the min terms is called the index. And what we do? Suppose I have 2 groups, let us say I have made 2 groups, one with index I have made another group with index I plus 1. Well, just repeating, what does index mean? Index means how many number of ones are there. Let us take an example, let us say I equal to 1. So, I equal to 1 means in this group of I will be having min terms like 1 0 0 0, 0 1 0 0 like this, there is a single one, and I plus 1 I will be having 1 0 1 0, 0 1 1 0 like this, where there are two ones. And what we do after that is that compare every term of the index I group, this group, with each term, every term with the group I plus 1. You compare, means every element from here with every element of here, and check whether they differ in a single position or not, and wherever possible you apply this rule. Okay. Now, if you are able to apply this rule, for example, here there was 1 0 0 0, here was 1 0 1 0, it was differing in one position, you could have applied. If you are applying, you put a check mark against the two elements, tick tick, that means you have applied rule here, right. This is something you do, and after you do this step 2, you compare the terms which have generated after this step in the same fashion. Generate some new term by combining two terms that differ in a single one again, dash in the same position. I shall show an example to explain what this means, and you go on repeating this combination process, combining process until no further application of this rule is possible. At that point, all the terms which are not ticked or not checked, they will be the prime implicants of the function. The point to note is that at every step, you will be comparing the terms of the index I group with the index I plus 1 group. Let us take this example worked out, and after that we shall work out an example by hand. Here the font size is a little small, but let us see. Here we have a function like this, where these are the true min terms 0, 1, 2, 5, 7, 8, 9, 10, 13, 15. There are 4, 5, 6, 7, 8, 9, 10. You see, first here in the first column, what we show here is we write down these 10 min terms in the order of the number of ones in their binary representation, that is the index. The first group consists of index 0, 0 is there, 0 0 0 0. Second group is index 1. So, 1, so index 0 is done, 1, 2 and 8, they have single ones 1, 2 and 8. Then group with index 2, we have 5, 9 and 10, they are with index 2. Then index 3, 3 ones, we have 7 and 13, and finally 15, which is index 4. So, for an n variable function, let us say for an n variable function, the index can go from 0 up to n, 0 up to n. Like here for a 4 variable function, we can go from index 0 up to index 4, right. This is what we do first. Then let us see what we have done. We compare this group 0 and group 1, index 0 and index 1. This is 0 0 0 0, this is 0 0 0 0 and 0 0 0 1, they differ in one position, you combine them, you get 0 0 0 dash, and you put a tick here, put a tick here, you have applied them. And here you write 0 comma 1, saying that 0 and 1 you have combined. You go on comparing 0 0 0 0, you compare with the next one also, 0 and 2 also you can compare, differs in one position. So, it will be 0 0 dash 0 this. So, this also is ticked. 0 and 8 can also be combined, one position, dash 0 0 0, tick. So, this comparison is done. Now, you compare this with this. So, all element of this you compare with all element of this and see that which can be compared, combined. 0 0 0 1 you can combine with 0 1 0 1, there is one gap. Okay. So, 1 and 5 can be combined, 0 dash 0 0, this will become dash 0 and 1 0 1. So, you also put a tick here. Similarly, this 1 and 9 can be compared, 0 0 0 1 and 1 0 0 1, dash 0 0 1, put a tick here. Similarly, 2 and 10, 0 0 1 0 and 1 0 1 0 can be compared, first one is different, dash 0 1 0, tick. 8 and 9 can be compared, 1 0 0 0 and 1 0 0 1, it will be 1 0 0 dash, already ticked. 8 and 10 also can be compared, already ticked. Then this and this group, Same way 5 and 7 can be compared, 0 1 0 1 and 0 1 1 1, one position difference, 0 1 dash 1, put a tick. 5 and 13 can be combined, put a tick. 9 and 13 can be combined, already ticked. Similarly, 7 and 15 can be combined, 13 and 15 can be combined. So, from the first column you generate the second column. Repeat this process as long as you can. Now, start with the second column. Same concept. Now, you have these 1, 2, 3, 4 groups. Compare first and second group now here. Same thing 0 0 0 dash, you see where you can compare. You can compare this with here 1 0 0 dash. You see 0 0 0 dash and 1 0 0 dash. Dash must be in the same place and 0 and 1 different. So, if you combine it will become dash 0 0 dash. You see, if you combine it becomes dash 0 0 dash, 0 1 and 8 9 are being compared 0 1 8 9. So, you tick this, you tick this. 0 1 you cannot combine anything else, 0 2, 0 2 is here, 0 2 you can compare with 8 10. So, this also gets ticked, 0 2 also gets ticked, 0 8 you can combine with 1 0 8 and 1 9. So, this will get ticked 0 8 1 9 and 0 8 also 2 10, 0 8 2 10, this will also get ticked. So, this is done. Now, similarly this and this, with all of this you combine, you compare with this, you see 0 dash 0 1, 1 dash 0 1, you can combine this. So, now this will also get ticked, this will. So, in this way you go on ticking, I am not showing everything, you go on ticking, I shall work out an example later. So, you get this, and after this here you see that after this step you cannot combine anything else here, you see this and this, you cannot combine anything more. So, whatever remains which are not ticked, which you call A, B, C, D, these are the 4 prime implicants. Dash 0 0 dash means x bar y bar, dash 0 means x bar z bar, dash 0 1 means y bar z, dash 1 means x z. These are all prime implicants. So, let me work out an example by hand, it will be clear to you. Let us take an example like this, which is simpler. There are 7 min terms 1, 2, 4, 8, 10, 14, 15. So, let me form that table like that. So, these correspond to the 4 variables A, B, C, D. So, there is no index 0 term. So, index 0 is not there. So, index 0 is blank. So, index 1 you have 1, 2, 4 and 8. 1 is 0 0 0 1, 2 is 0 0 1 0, 4 is 0 1 0 0, 8 is 1 0 0 0. Then you have index 2, index 2 is 1 10, only 10, 10 is 1 0 1 0. Index 3 is only 1 14, 14 is 1 1 1 0 and index 4 lastly 15, 1 1 1 1. These are the initial groups. Now, from here let us form the next level groups. Let us see, let us compare this with this 0 0 0 1, 1 0 1 0 we cannot compare, 0 0 1 0 and 1 0 1 0 you can compare, they differ in one position. So, I put a tick here, I put a tick here, and if I combine what I get, I combine 2 and 10, right, 2 comma 10, what I get dash 0 1 0, dash 0 1 0. Then you continue comparing, you cannot, this 4 and 10 you cannot compare, but 8 and 10 you can compare. 8 and 10 is differing in one position again. So, you put a tick, write 8 comma 10. So, it becomes 8 and 10 1 0 dash 0 1 0 dash 0. So, this group is done. Now, compare this and this 1 0 1 0 and 1 1 1 0, they can be merged differing in one position. 10 comma 14, it becomes 1 dash 1 0. Similarly, 14 and 15 you can combine, 14 and 15 1 1 1 dash. These are all ticked, right, but these two are not ticked, 1 and 4 are not ticked. So, you continue with this, try to merge this and this. You cannot merge anything because the dashes are not in the same position. Similarly, here and here you cannot merge anything more. Okay. So, there are 1, 2, 3, 4, 5, 6 prime implicants which are unticked or unchecked. So, your prime implicants are, in this case, first one is 0 0 0 1, which is A bar, B bar, C bar, D. Second one is 0 1 0 0, A bar, B, C bar, D bar. Third one is dash 0 1 0. So, A is not there, B bar, C, D bar. 1 0 dash 0, A, B bar, D bar. 1 dash 1 0, A, C, D bar, and lastly 1 1 1 dash, A, B, C. These are the 6 prime implicants for this function, and using this tabular method I have identified all the prime implicants, right. Let us work out another example for your convenience, and it will be clear for you. Let us take this example. Here in addition, I am showing some do not cares. So, this do not cares also I am including in my table to form the prime implicants. So, in the first step do not cares also will be included. So, I am showing the table again. This ABCD I am not writing same way. So, there is a 0 index true min term here 0 0 0 0, then 1 index there is, who is 1 index, 8 is here and 2 is here, 2 and 8, 2 is 0 0 1 0, a single one, 8 is also single one, 1 0 0 0. Then 2 in the index 2 will be 3, 5 and 10. 3 is 0 0 1 1, 5 is 0 1 0 1, 10 is 1 0 1 0. Then index 3 we have 7, 11 and 13, the remaining 3, 7, then 11 and 13, that is it. So, you continue the same process, go on combining, try to combine this group with this group, 0 and 2 gets combined. So, you tick here, it becomes 0 0 dash 0, 0 and 8 gets combined, dash 0 0 0. This is the first group, then do it this and this, these are ticked. So, 2 you try to merge, 2 and 3 can be combined, 2 and 3 becomes 0 0 1 dash, then 2 and 10 can be combined, dash 0 1 0, and then 8 and 10 can also be combined, but it does not add any more tick. 8 and 10 will be 1 0 dash 0. Now, the next one 3 and 7 can be combined, 3 and 7, 3 7 is 0 dash 1 1, then 3 and 11 can be combined, 3 and 11 dash 0 1 1, then 5 and 7 can be combined, 0 1 dash 1, then 5 and 13 can be combined, dash 1 0 1. So, you have this step. Now, you continue with that. In the next step, you see that where you can combine this group and this group. Here you can combine 0 2 and 8 10, 0 2 and 8 10. So, you get 0 2 8 10, you get dash 0 dash 0 dash 0 dash 0. Similarly, 0 8 and 2 10 you can combine, you will get the same thing, they will also get ticked, and 2 3 remains. And similarly, if you combine this group with this group, there will be another one generated 2 3 10 11, 2 3 10 and 11, 2 3 with 10 11 0 dash dash 0 1 dash dash 0 1 dash. Yeah. So, you see whatever there is unticked now, this one, is it correct? I think this is not correct. Let me check it once. 0 to 8 10 it is done. Then here whatever 2 10 and 3 or 2 10 and 3 11. Okay, 2 10 and 3 11 can be combined. So, it will be 2 3 10 11. Okay, that is fine. It was right. 2 3 10 11. It was right. 2 3 10 11. It is dash 0 1 dash dash 0 1. Yeah, that is right. Fine. So, how many are remaining unticked? This is 1, 2, 3, 4, 5 and 6. So, there are 6 prime implicants here also, 6 prime. So, you can list them. So, whatever. This one for example, will be A bar B bar C, A bar B bar C. This one will be A bar C D, A bar C D. This one will be A bar B D. This will be B C bar D. This will be B bar D bar, and this will be B bar C. So, in this way you see you can follow this systematically, you can do it by hand, you can generate all prime implicants of the function. This is the first step of the tabular method. This method can also be automated, you see systematically you can do it, you can also write a program to do this same thing. Okay. So, the next step which we shall be discussing in our next lecture. So, once you have obtained the prime implicants of the function, well, we know earlier that among the prime implicants some of them may be essential, while some may not be essential. So, now our task is to select the minimal set of prime implicants that covers all the true min terms of the function, Of course, we must include the essential prime implicants, in addition some of the non-essential prime implicants. So, in the next lecture we shall be discussing a systematic method for selecting the set of prime implicants to cover the function, that will complete this method. Okay. So, with this we come to the end of the present lecture. We shall be continuing with this discussion in the next lecture. Thank you.